Well, I'm really pleased to see such a turnout, and we both are. My friend and colleague, Bill Sheehan, and I first cottoned onto this whole business about the space age generation a couple of years ago, because we tried to make it clear to people that all of the excitement of the space activities we have today, the landers, the flybys, etc., really only began relatively recently. But what it did begin with was the launch of Sputnik. Are any of you old enough to remember when Sputnik was launched? If you don't raise your hand, I think you're liars. But anyhow, uh, that really was a trigger for me. And Bill is a lot younger than I am, or he claims to be. So he doesn't remember Sputnik, but he doesn't remember very much anyway, because he's a psychiatrist. What could he? Yeah, very good. All right, this is the book we put together, and we have some copies if you're interested in buying some. This was a compilation of uh, 12 total authors, including Bill and me, and we wanted to make sure that many of the people that had begun being nerdly kids in the 1950s at the launch of Sputnik, and then became real astronomers, real space scientists, and others who, like Bill and me, just retained an interest in that topic for as long as we could. So here we go. All right, if you can't hear me, just holler. If you have any questions, let me know too. So next slide. So October the 4th, 1957, really was a day that shook the earth in many ways, because we thought, us Americans thought, that we were going to launch the first satellite during what was then the International Geophysical Year from 1957 to 59, I think. And part of that was to launch a satellite that would circle the Earth and give us information about things we didn't know about then. Well, the Russians beat us to it. And this really, as you can see from these headlines, this really shook the world, not just the American world, but many of the other people in it, because this was a complete unexpected secret. Basically a year later, we finally launched our satellite, the Explorer 1, which is being held up here by three very famous people at the time, including, if you remember him, Werner von Braun, who was a German V2 developer and inventor. And after the war, he came to the United States, and essentially that war weapons technology was then applied by the military, of course, and other reasons to really build rockets for space use and other good things. A year after that, whoops, pushed the wrong button. Let me see, there's a laser pointer here. There we go. No, well, anyway, never mind. If you look on the right, 1961, the Russians surprised us even more by launching the first man into space, Yuri Gagarin. This really, really shook us, and the space race went into high gear at the time, because the fear was that the Russians, during the Cold War, would launch weapons into space that we could do nothing about. So this was really pretty scary stuff at the time. But then we beat them to the moon just a few years later. And some of you may remember, I got to get this pointer going. This is the picture I remember being up at 2 o'clock in the morning when Neil Armstrong first set foot on the moon, and these incredibly fuzzy pictures, but it was so thrilling and exciting. And when he said the famous words, "That's one small step for man, one giant leap for mankind." And so we had come from science fiction, here's a sketch of what was believed at the time to be rockets circling the moon, to the real thing. And it was indeed exciting. And here are those heroes of ours in this wonderful picture. Over here, you see this iconic picture of Buzz Aldrin walking on the moon, and you can see here the foot of the lander. So if any of you doubt that we actually ever went to the moon, I think this might dissuade you. But there still are people who believe that. Well, these were also turbulent times. really turbulent times because World War II basically had just finished in the minds of most people. We then had the Cold War to deal with, which essentially involved the separation of the world into democracies, the good guys, or communists, the red guys. And so you see the globe, a map of the globe showing all the countries or the portions of the earth that belong to both sides. We had the Korean War, Vietnam War, and then the Cuban Missile Crisis in 1961, which terrified everybody because we came very, very close to World War III, which would have been a nuclear war, and God knows what would have happened. However, as it ended up, it was really a period of potentially mutual annihilation because had the war started, they had enough nuclear weapons and we had enough nuclear weapons to cancel each other out and say adios to everything. It was also a good time, though, because the Make Love Not War movement started socially. I don't know how many of you were peaceniks or anything like that, but this little token tells us all. It was the time when women's liberation movement began because women had been so suppressed. Prior to that, they couldn't go into science, they couldn't do many jobs, this, that, and the other. Chauvinism was rampant, but that started to change things. Also, some awareness at the time that, hey, the world's population is growing too fast and we have to do something about our environment. All that started way back then. So it's something to keep in mind. And yet, despite all of this, we managed to make it to the moon and the planets. What was known about the moon and planets at the time? Well, really not much, because all we could do is study them telescopically. The moon was close enough, we could get some ideas and details, but the planets just were too far and they would look like little disks, you know, in a telescope, and you could say, oh yeah, that's Saturn, it's got rings, and there's Jupiter, it's got its moons. And once in a while, Mars comes by, and maybe it's got canals on it, maybe not. But Chesley Bonestell, who was a premier artist at the time, space artist, he painted these incredibly nice paintings and very accurate in many ways because he predicted that eventually we'd be going to Mars. Left on the left here, up top you see Saturn as it supposedly would look from one of Saturn's moons. And then the bottom here is that hope for maybe some of the lines that people thought they saw on Mars might actually be water, bodies of water, because the polar caps might be melting and water might run across Mars, and maybe there was even some vegetation. Well, we didn't know much because most professional astronomers, as it turned out, were not interested in the solar system. That was sort of considered old hat at the time. The exception being a few at Lowell Observatory and Kuiper at Yerkes Observatory. But most astronomers were concerned with galaxies, with cosmology, the expanding universe, and so on. And so essentially, amateur astronomers, the only thing in those days any amateur could do was to use their telescope to look at a planet or at the moon and make sketches, maybe the occasional photograph, and kind of monitor things that way. It was fun for us, and that's how most of us got really into it. To give you an example, Venus, our closest planetary neighbor, by the way, if any of you want to see it, you can see it by naked eye evenings now, just after sunset. It's this bright, bright object close to the sun. Through a telescope, it looked bland with a few little gray shades. Photographs weren't much help. Whoops, I pushed the wrong button again. And so we didn't know what was under that thick layer of clouds. What was under it? Steaming jungles, water worlds, arid deserts, maybe even life. And imagination went crazy because, see this incredible depiction here? This was thought to be, if there is a steaming jungle under Venus, maybe you have these weird kind of dinosaur-like animals as well. No evidence for any of this, but it was fun to think about. Today, this depiction here shows part of the Earth. Of course, on the right here, our beautiful planet with clouds and oceans and continents. This is a comparable image of Venus, which is almost the same size as the Earth, except this was taken through radars from various spacecraft that had been there, and were able to show that once you strip away the atmosphere, so to speak, or you can penetrate it, Venus was a volcanically rich world. And the atmosphere on Venus is thick, toxic, and about 96% carbon dioxide. As a result, and the clouds on Venus are acidic. They have sulfuric acid, just a wonderful place to visit. And runaway greenhouse effect. The temperatures on Venus are about 800 degrees Fahrenheit. So if you want to go there, if you like Phoenix, this is a step well higher. Fire breaks down is great. Well, you don't need it. They're active volcanoes. Recent information, again, from satellite and space probe idea suggests that there's still volcanism going on Venus, which is very exciting. And there's maybe even a possibility that there might be microbes living in the clouds somewhere. We don't know yet, so stay tuned. Mars, these pictures of Mars, I remember seeing them in Life magazine. The ones on the left are beautiful first color photographs of Mars, taken at that time in 1954 by William Finson. And what you see there is the kind of thing everybody liked to see, because it sort of suggested, see this slightly greenish, bluish, maybe that's vegetation. And these lines, well, the canals aren't what Percival Lowell thought they were, but maybe these long streaks are somehow growth of vegetation. The problem was they used ectochrome film and under conditions that it wasn't intended to photograph. And so the color shift during development is all wrong. That's why it looked much more inviting, really, than it is. Over here is a much better photograph of Mars than, oh, well, I just have to stop playing with this thing. Hold on, almost there. All right, don't look, close your eyes. It's stuck now. Okay. Well, enough of that. So what were we doing as young upstarts? This is a picture of my rear end on the right. I had just turned 16, so I was allowed to join the Royal Astronomical Society of Canada in Toronto, which was quite a privilege because it contained both amateur and professional people at the time. Beautiful comet Aaron Rowlands was visible then, even from cities like Toronto, which was a fraction of the size it is now, and there wasn't so much light pollution. I actually thought I might have discovered it until the next day in the newspaper, I found out otherwise. And then the National International Geophysical Year, and that's the picture of Sputnik as portrayed by, at the time, really just a big ball of steel and stuff, and it went beep, beep, but it was so much fun to realize it was up there. Okay, we had more dreams. This is my distinguished colleague down here, not up there, that's my baby sister, this gentleman here, and he was so, shall we say, keen to get a big telescope, he tried grinding his own mirror, which a lot of people did at that time. And the fact that he even attempted it is laudatory. This is my sister showing us the telescope that I managed to build with my help of my father and her, and buying the optics. Notice how sophisticated the mount is. It's pipes, right? And so we used to call those mounts plumber's nightmares. What I really wanted was a telescope like this, complete with this attractive young lady. But you know, I couldn't afford it. Or something like this. This was sort of state-of-the-art refracting telescopes. And this whole setup would cost something like $500–600, which was totally out of reach. It would be like $5,000–6,000 today. So we had to make our own very often. Now, the other thing we had in those days was we had some real superstar mentors that we perceived. And this is one of them is called Walter Haas, who was the founder of the Association of Lunar and Planetary Observers. He encouraged, as did Patrick Moore, the gentleman on the right there next to my colleague Bill, and I'll let him talk about that in a minute. But here we are at a convention on the left of the Association of Lunar Planetary Observers. Walter was a terrific mentor to young people at the time because he was a teacher at New Mexico State, I think, of math, but he loved astronomy. And so here you see him, me, and another friend, and this young lad over here, Clark Chapman, who is in fact one of the authors of our book, and he is a renowned solar system astronomer, now retired, and he contributed a lot to this whole story. Bill, would you like to tell us about Patrick Moore?
Just take this thing.
Oh yeah, I guess you'll have to, won't you? And this one too. We'll get it done. Yeah, put it in your pocket.
Did you get that?
Yeah, he already
Got it.
has it.
Oh. I'm like an astronaut. So, well, let me just briefly, I won't interrupt the flow of Klaus's presentation, but let me just start by saying, again, I'm about 10 years younger than Klaus, so I just turned my biblical 70. And it looks like there are a lot of other golden agers out there too. But when I grew up, one of the things that was very different from today is that one was several years behind in terms of the latest things that were going on in astronomy. The main source of information that I had was the local branch library. And I would get books. The shelf was dominated by books by Patrick Moore, who was just an incredible force of nature, who I think at the end of the day, depending on whether you count some of his second editions or not, or third or fourth or fifth editions, had something like 100 books that he wrote over the course of his lifetime. And one of the jokes is that he wrote 100 books or one book 100 times, because there was a lot of redundancy in that. And he was a personality on television as well. He was very lucky because the BBC interviewed him to take on a program. They were going to do several programs just to see how it went on astronomy. And one thing that he was able to do was talk spontaneously and with a very, it sounded like he was announcing a horse race or whatever. He had a really fast pace. Well, they debuted him in April of 1957 when Comet Aaron Roland appeared. So he had a comet that sort of introduced him, as it were. And then in October of 1957, Sputnik. So the timing was perfect. And one of the things about that era was, as Klaus emphasized, there was so little that was really known that a single person was self-trained, never went to college, was able to sort of cover the waterfront and write books about these things that were engaging and, you know, reasonably like hit the side of a barn accurate and compelling to the public. And one of the things he emphasized was that even an amateur astronomer with modest means of observing, means of equipment, nothing more than your own eyeball, trained hopefully, with a sketch pad and a telescope that you could either make yourself or, you know, if you had the means, acquire, you could do useful work. You could actually contribute to science. You could observe the clouds of Jupiter and make timings to work out the circulation patterns. There was a lot of controversy about what the origin of the craters of the moon were. And he was an authority that somewhat dogmatically and inveterately insisted that all of these were volcanic features at the time when people were just working out that perhaps meteorites were much more likely to be the cause. So it was a tremendously exciting thing. And the idea that you as just an amateur astronomer could make contributions to science was just exhilarating. And a friend of mine was once waxing eloquent about doing useful work. And his wife said, well, if you want to do something useful, take out the garbage. I'll take back.
Good. I'm glad you filled that in, Bill. Right. So when the gadgets.
Something from his phone. Should be able. Right.
An inveterate thief.
All right, can everybody hear me okay? Okay. All right, so that kind of sets the stage. The other thing that we really were excited about, because there was no internet then. We had local clubs and, you had some publications and so on. But the one that was basically our Bible was called Sky and Telescope magazine at the time, was very authoritative, and a lot of professionals also used it. And it was sort of a blending of two prior magazines, the Sky and the Telescope, and neither one of them was doing very well. So they merged and reformatted and became really a best-selling magazine, and still is today quite an authoritative magazine for astronomy. Now, some of us became professional astronomers, as I mentioned, and especially in Arizona. These lads up here with their big telescope included, among others, Dale Cruikshank, William Hartman, Charles Wood, Alan Binder. And they were all students at the University of Arizona, where the newly established Lunar and Planetary Laboratory had been founded by essentially the university. And also, this is Gerald Kuiper, who was a Dutch-American astronomer interested in the solar system. And as the Apollo era approached, they discovered that we could go to the moon, but our maps of the moon were totally inadequate for the time. And so he got together, among other things, and essentially started a lunar mapping program. Here you see a picture of it, wonderfully detailed observations based on photographic positions. But at the time, it was a lot easier to see things with the eye than even the best films of the day could record. And so, for example, Global Observatory was part of that program. And observers would look at these developed maps from photographs and then fill in what was not recorded on film. And this way, essentially started getting, yeah.
One thing about the maps before Kuiper and the group was that a lot of them were hand-drawn. And the largest map was a 300-inch map by Patrick Moore's colleague, H.P. Wilkins, who was a civil servant, and he devoted his whole life to mapping the moon. He was an unskilled draftsman, and somebody once said about his map that it looked like it was made by a drunken or demented spider.
I didn't think you were going to say that. Poor Wilkins. Today, if you haven't been to USGS Astrogeology Unit, I urge you to go. This is now one of the most recent maps or up-to-date maps of the moon based on astronaut return, sample return, photographs, orbiters, etc. And all of these geological colors indicate in detail what the rock type is, what the chemical composition of these things are. That's how far we've come in that interim, just to contrast to what was available then. Now, it wasn't just the boys, incidentally, who were interested. Some girls made it through as well, despite all of the nasty things trying to prevent them from doing. Two of our authors are these two superstar ladies, Barbara Lukita, who actually lives here in Flagstaff. She was involved in mapping many of the planetary images today of Mars and the Moon. And then Yvonne Pendleton, who is the youngest of our group of authors, who is still very active with NASA today. These ladies had to overcome so many prejudicial barriers. It's amazing they made it, but they had the persistence, they had the brains, the tenacity to do it, and hats off to them. Here's some of the stuff that we would spend hours and hours doing. These are some sketches that my group in Montreal made of Mars, and we even made a map of Mars for the 1960-61. Some sketches of Venus, everything by eyeball with maybe some filters, and as Bill said, pencil and eraser. Some of us were more talented craftsmen, and this is some of Bill's work. Beautiful sketch of Saturn, Jupiter, and the crater Heliodus on the Moon. And these would then be published in the Journal of the various astronomical societies then. And they didn't contribute directly to science, but they sure were fun. To give you, this picture says it all in my mind. Here's a sketch that I made of Jupiter in 1961, showing you, this is the moon, some of its moons. Here's the moon. Oh, for heaven's sakes, Brasch. I'm all thumbs with these things. There. You see this? This is the moon Io, the closest moon to Jupiter, and it's casting its shadow on the moon because the sun is behind us here. Here's one of the other moons. And this is what the great red spot, which is a long-standing tornadic-like storm on Jupiter and Jupiter's atmosphere. All you see is atmosphere. Nowadays, we have the Juno spacecraft, which has been circling Jupiter for a very long time, and happened to catch a transit across the red spot. Look at the difference in resolution from this to that. It just speaks volumes as to how far we've come. I did a little bit of astrophotography. I'm so proud of these grainy pictures. And I couldn't afford this camera on the right. Way too expensive. So I made one. See the little one on the left? It's a toy Bakelite. You remember Bakelite? I made that, and I used wax paper as a focusing screen. Load it with film, stick it back in, and take pictures. It was fun, and you felt you were doing real science. So what have we learned since? This is perhaps more important. Well, the solar system is far more complex than anybody could have guessed at the time. And you just have to look at NASA pictures and other pictures to appreciate that. A new golden age, really, of solar system exploration is just beginning because we're sending more probes out there. We're probably going to continue in that direction. Also, planetary systems, as we've since discovered, through exoplanet, in other words, detection of planets around other stars, nearby stars to us. There are so many of them. Almost every star we look at has some form of planet, although they're not anything like our planets, but they're out there. And our Earth may well be rare or unusual, so let's treasure it. Several moons of Jupiter, Saturn, and possibly Mars in the past, and Venus may actually have harbored or still harbor life. So this is really exciting. I'm a biologist by profession, and astrobiology would be what I would do today if I were that age. So the best is yet to come. Is Pluto still a planet? How many think it is? How many don't?
Yeah.
It's a dwarf planet, a tiny little planet, yes. Is it grumpy or no? Okay. Now, the NASA missions of today are very much focused on trying to determine if there is life out there, or at least the elements to have life. And one of these targets is this beautiful, intriguing moon, Enceladus, one of Saturn's moons, because it's covered with ice, but we now know that there is an ocean of water just underneath that ice. And as the Cassini space mission discovered, there are vents at the South Polar region where essentially water vapor comes spewing out. It's probably salty water, and there's some indication it might have organic compounds in it. Well, the other one that's equally intriguing is Jupiter's moon Europa. And as you may have read recently or heard, we are about to launch another probe to that moon called the Europa Clipper, jointly with NASA and the European Space Agency, specifically to look for evidence of biological activity. You see here at the bottom, this is just the portion of the moon Europa. This is a depiction of the spacecraft that isn't there yet. But what you see is all of these curlicues and cracks. Those we know now are the outer ice cracks. And once in a while, contents from the interior spew out. And those may be perhaps indicative that there is life under the surface, just like there is on our deep ocean floors. Europa, it's a very small moon and it's very little gravity, probably relative to us, but that probably wouldn't matter if there was life there, it would do just fine. How about that? Yeah. The future, well, back to the moon is probably one of the things we'll do. This graph is a little outdated date-wise, but the idea, of course, is, as you know, we and the Chinese and perhaps India will eventually try to get back to the moon, perhaps have manned missions out that way, because we know that there is some ice on the moon at the dark polar cap, so that would give us water if need be, and so on. So again, there's lots of excitement about the future of space travel in this regard. Manned mission to Mars, people are talking about it. And Mr. Elon Musk, as you know, is trying to push that forward. And many of us shudder at the thought, because to go one way to Mars wouldn't be very good.
Step for him is he hasn't been able to find any co-pilots.
Ah, very good. He has no co-pilot. Anyway, but eventually I'm sure some form of us will end up on Mars for exploration. And then to me, the most exciting thing that's happening now is we've discovered more than 5,000 planets around other stars, exoplanets. And it's interesting, of the sample that we have, which relative to the number of stars and probably the number of planets that we're going to find is minute sample, but still, based on that, as we can see, most of these planets are, whoa, not again, Brasch. Oh, for heaven's sakes. I'm hopeless. How do I get back on this? Help. I'm all thumbs. This is awful. You think? Yeah. Can I quickly go through? Yeah, this is ridiculous. It's not on that computer. It's the one back there, yeah. So there goes my grand finale. I botched it. But hang in. Pardon? Yeah, I'll be almost done. And I want you to fill in a couple of closing thoughts. Okay. Keep going. Bit more, can you go? Further. I'll tell you when to stop. Next. Next. Okay, perfect. This pie chart shows you that about 1/3 of all the planets we've discovered so far. Mind you, it's easier to discover big planets than small planets with our technology today. But about 1/3 about the size of Neptune, 1/3 the size of Jupiter, huge, huge gas planets. About a third are what are called super Earths. They're rocky planets, but much bigger than the Earth. And only about 4% of these are truly Earth-like in size and so forth. So obviously, you know, when we look at our own Earth, this should be a message, treat it well because there may not be that many out there kind of thing. We certainly could never visit any of these, but there's something that tells us in some ways our solar system is quite unique. And then there's always this, the possibility that we will, through search for extraterrestrial intelligence, I hope we find some because there ain't none here, folks. And they're now using radio telescopes and other devices with incredibly powerful new technology that can sift through some of this mess of signals that are being collected. And perhaps using artificial intelligence would be able to sift out those that are natural, those that are artificial, in other words, from some advanced civilization, as opposed to natural background. And this may be the future of human evolution. This would be the AI man in the very front. I don't know that. It's just some cartoon I thought would fit in here appropriately. Having said that, my friend William will give us some concluding marks if we have the time.
Ask people their rules.
Yeah. We'll put that in there. That me? No. And there's one more. Yep. There you go.
All right. Well, I'm not going to speak very long, but what I would like to do is kind of give you a little bit of my perspective and maybe make some suggestions of some of the larger themes that have emerged. I mean, one of the advantages of getting older is you sort of live life in double. You not only remember what it was like going along the trail the first time, but you can look back with the perspective and see from whence you've come. So when I look back to the early period of my interest, some of the things I didn't fully appreciate was that I was living during a time that was going to be a unique adventure for humanity. Someone once said that we're able to explore the solar system for the first time only once. And that is what happened between the late 1950s and probably the end of the 1980s, when for the first time, these planets that in ancient times just appeared as small disks to the naked eye became first tantalizing worlds that were as much of dream as they were of reality, that we peered at with endless fascination in these small telescopes and sketched relentlessly and hoped to make small discoveries about, to worlds in their own right that were, you know, incredibly, as Klaus said, complex and interesting and remarkable. We saw Mars for the first time from Mariner 9 when we discovered there weren't canals there, but there were more interesting things geologically. Huge shield volcanoes and canyons that bedwarf the Grand Canyon of Arizona, and dry riverbeds. And Jupiter was this mass of riotous colors and clouds that were continually forming and changing, and moons that were each a world unto itself. Io with its volcanoes. Klaus mentioned Europa with these strange lineations. Saturn, whose rings were always the showpiece of the solar system, and all the intricate structure that was revealed within that, and Uranus and Neptune, people that spent their whole lives studying these as analogs to stars that reflected sunlight perfectly like mirrors, so that they could assess whether the sun's brightness changed, because they were so far away that they didn't reveal any detail. So it was an era of just unprecedented exploration. So there was that, and the people that grew up during that time saw planetary science emerged in its own right in a completely different way from what it had been before. As Klaus said, until the 1950s, when people like Gerard Kuiper got interested in studying the moon and planets, professional astronomers had more or less abandoned the solar system. They were interested in working out ionization of gases in the atmospheres of stars and extragalactic problems that were much larger and seemed much more important and much more appropriate to study with large telescopes, like the ones at Mount Wilson, Mount Palomar. And suddenly the solar system became fashionable again. And why was that? Because there was a lot of money going into it. John F. Kennedy in 1961, during his speech to the joint session of Congress, created the perfect mission statement that any organization should embrace because it had several features. We're going to send a man to the moon and return him safely to the Earth. That's the goal, clearly stated. It wasn't, we're going to send people to the moon, maybe, or to Mars, or maybe we'll save the economy by building a wall to prevent Mexico from invading. It was very clear. He set a timeline by the end of the decade. And the other part of his mission statement was that any amount of money that it was going to take was going to be thrown at this thing. So at its heyday in, I think, 1965, 1966, there were hundreds of thousands of people working for NASA as part of the Apollo program. And NASA's budget was higher than it would ever be again. It was 4% of the federal budget went to NASA. And so it was the era that was described as the era of budgetless financing. And Kennedy himself, in a tape that he made, was recorded in 1963, that was finally released by the Kennedy Library in 2001, said, "I'm not that interested in space. I think it's good, I think we should do it, but it's going to be really expensive, and the only thing I'm interested in is beating the Russians." And that's kind of the dark underbelly of this wonderful era of exploration, is that our motivation for doing it was not primarily to advance human knowledge. It wasn't to discover facts about the solar system. It was basically a sublimated contest as to who could build the more powerful ballistic missiles. And so when we demonstrated with Saturn V in particular that we had beat the Russians with that, the subliminal message wasn't, oh, look, we made it to the moon. Wasn't it going to be great? Americans lead in the exploration of this other world. It was, we could put a nuclear warhead that's really big on that thing too, if we wanted to. So there was all of that. And one of the less positive things that come out of this was, of course, there was tremendous exhilaration when Apollo 11 landed. But by 1970, when Apollo 13 had an oxygen tank blow up on the way to the moon, and there was coverage of this, people were irate. Why? Because these broadcasts about what was going on Apollo 13 were interrupting the daily soap opera schedule. And the greatest irony is one of the soap operas was called Another World. So the point is that when we look back over this era, it's still being written in terms of what it's meant for humanity. And we did see Earthrise over the moon, which was so spectacular. And so many people said, this is going to completely change our perspective. We're no longer going to see, when we look at the Earth from space, borders between countries, differences between nationalities, races, whatever. We're going to see that we're all part of this thing. And we need to solve these problems together and protect this planet. Well, unfortunately, as we look back to 1968, from the perspective of 2024, it is unclear that that's the lesson that has sunk into this thick skulled primate mammalian species we call Homo sapiens. That's all I'm gonna say. Now you're depressed.